12-3, trig functions of general angles, day 1. All right, so I've taught most of this to you, so let's just start. It says theta is 150, but the instructions say the initial side must be on the positive or negative x-axis, and theta must be acute. That's a little confusing, so we're just going to stick with our program. Always start there. Always. This is a positive 150, which means up, so keep track of this stuff. There's 90. We got to go 60 more and be semi-accurate with your drawings. It's going to help you in the long run, I promise. And so remember what I told you guys. The reference angle will always be sandwiched between the spinner, which is right here, and your x-axis, which is right here. If you need to label it, label it. But this is my reference angle, which, by the way, I can't use theta because that's already 150, so I'm going to use this fancy thing called alpha, and that would be whatever's left over. So that would be 30 degrees. All right, so this says state the quadrant and the measure of the reference angle, alpha, for each angle, theta. So theta is how far you're going to spin your spinner, and this is going to be your reference angle. So let's just do it. So we start here, always. It's positive, so we go up. I know that's 90 plus 90 plus 90, which is 270, and keep track of these little details, which means I need to go 30 degrees farther. Now, a lot of students will say, aha, there's my reference angle. No, because this is sandwiched between my spinner and my y-axis. I need this because it's sandwiched between my x-axis and my spinner. So this would be 60 degrees, but we're in the fourth quadrant. 225. There's your spinner. You're going to go up 180. How much farther do you need to go? 45. Notice this is 45 degrees. This is sandwiched between my spinner and my x-axis. So this one, I don't need to do anything with it. That's my answer. That's my reference angle. So alpha would be 45, and I'm in the third quadrant. This one, we got to go down. So there's my spinner. We got to keep track of stuff and be semi-accurate. How much farther do I need to go? 30, which means not very far. So this is 30 degrees. So is this my reference angle, or is this 60? Which one? It's got to be this one, because it falls into my definition. It's sandwiched between the x-axis, which is this, and my spinner. So it's 30 degrees. So alpha would be 30 degrees, and I am in the second quadrant. That's what this quadrant is. 440. So this means we just got to go around 360. And then ask ourselves, how much farther? Well, we need to keep going 80 and then stop. That's where it would stop, right there. So this is 80. This little sliver's 10. Which one is my reference angle? This one. So that's my reference angle, and I'm in quadrant 1. Negative means down. So I start here. I go down 360. And then I ask myself, how much farther do I need to go? Well, that would be 70 more. And if my spinner stopped right there, that means this angle would be definitely 70. That's my reference angle, and I am in quadrant 4. Now they're going to actually have you do some trig. Find the 6 trigonometric functions. So sine, cosine, tangent of theta. So we're going to throw our little theta in there. And it says, whose terminal side, don't like this, passes through, I like, stops at 8, negative 15. 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to label that. And then down 15. I know this is 10. So I go 1, 2, 3, 4, 5 more. And this is where my spinner stops. This is 8. Now you got to keep track of the sign here, negative 15. I know in geometry class you were taught you can't have negative sides to triangles, but trig is now going to trump geometry and say, no, it's definitely possible because this is down. So now that's how you would get to that point right there, because that point is 8, negative 15, so we have to include the negative. Now if you remember from geometry, there's 3, 4, 5 families. There's 8, 15, do you remember? 17. There's 5, 12, 13. And there's 7, 24, 25. In this case, we have an 8, 15, 17. Your hypotenuse is always, 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 always positive. Don't forget that. And if you don't remember this, then of course you could go a squared plus b squared equals c squared, and you'll end up getting 17, I promise. However, where's my theta? It's right here. Again, back to what I've said a lot. This is my x-axis. This is my spinner. So it's got to be right in here. All right, well, this is opposite over hypotenuse. This is adjacent over hypotenuse. This is opposite over adjacent. So now we just got to figure out what our parts are. This would be my opposite. This would be my adjacent. This we've talked about is our hypotenuse. Now we just put things where they belong. So my opposite, negative 15 over hypotenuse, 17. Cosine is my adjacent, 8 over my hypotenuse, 17. Tangent is opposite over adjacent, so that'd be negative 15 over 8. And now you just have to remember that cosecant is the flip of sine. And so typically you just keep the negative in the top. And a few students say, well, I thought you said the hypotenuse can't be negative. It can't be. But in math, you just kind of keep the negative up in the numerator. That's just normal. And so secant, we flip this, 17/8. Cotangent, flip this. And again, you're just going to keep the negative in the top. And that's it. There you go, guys.